Hello, welcome to the last lesson of our trigonometry functions unit. This is solving three-dimensional problems by using trigonometry. Okay, get right into it. We're going to be using primary trig functions, sine law, and cosine law. From point B, Manny uses a clinometer to determine the angle of elevation to the top of a cliff to be 38 degrees. From point D, 68.5 meters away from Manny, Joe estimates the angle between the base and the cliff himself and Manny to be 42 degrees, while Manny estimates the angle between the base of the cliff and Joe to be 63 degrees. How tall is the cliff? Okay, a confusing word problem, but the first step we want to do is draw a diagram. Okay, so we have the top of a cliff, and we have two people. Okay, Manny and Joe. So the cliff is 90 degrees. Okay, 3D shape. And the information that we know, Manny's looking up at the cliff at 38 degrees. "63 here, 42 here, and Manny and Joe are 68.5 meters away. Okay, step 2, or B, is the process. So what are we going to have to do in order to solve how tall the cliff is? First thing we need to do is find angle A. Okay, so A is right here. Then we are going to have to find the side length of MA, so Manny and the base of the cliff. And then the last thing we're going to have to do is TA, so the height of the cliff. Okay, and then step C is to start solving. So number 1, angle A. Well, we know the two angles in the bottom two triangle, so we can subtract the 63 and the 42 from 180. And we're going to get 75 degrees. Okay, so this is 75 degrees. Now we can use sine law to find the length of MA. Okay, and this is step 2. So sine law, we have x over sine 42 equals 68.5 over sine 75. So x is 68.5 times sine 42 divided by sine 75, and we figure out that the distance between Mandy and the bottom of the base is, 47.5 meters. Okay, so x is 47.5. I'm just going to quickly draw what's left because we have the Manny triangle. It looks like this. It's 90. Manny's looking up at 38 degrees. We just figured out that the bottom of this triangle is 47.5 meters, and we want to find y. Okay, so opposite and adjacent, we're using tan, so tan 38, this is step 3, equals opposite over adjacent, variables on top, so we multiply 47.5 times tan 38, and the height of the triangle, of the cliff, is 37 meters tall. I'm going to make it 37.1 meters tall. Okay, Next, Emma is on a 50-meter high bridge and sees two boats anchored below. From Emma's position, boat A has a bearing of 230 degrees, and boat B has a bearing of 120 degrees. Emma estimates the angles of depression to be 38 degrees for boat A and 35 for boat B. How far apart are the boats? Okay, so first thing we need to know, and you probably don't know, but just in case any of you decide to be a sailor or a pirate, we need to understand bearings. Okay, and bearings start at the top. The top is 0 degrees, and unlike our quadrants, our Cartesian plane, we count clockwise for this one. Okay, so boat A is at 230 degrees. So we count 90, 180, 230. So 230 is about there, and that is 230 degrees. Boat B is 120 degrees. So we count 90 and 120. Okay, so these are how our boats look. And to find the angle in between them, let's do blue. So this angle in between the two boats, we're doing 230 degrees minus 120 degrees, which is 110. Okay, so the two boats have an angle of 110 degrees between them. Okay, why is this relevant? So Emma is up here. It's drawn the same way as the Manny one that we just did. Sorry, let me move it over. It's 3D. This is actually 90 degrees. Okay, so we just figured out that this is 110 degrees. So we have A, B, the cliff is 50 meters, or sorry, the bridge is 50 meters. Angle of elevation, so this is a 3D triangle, so it's parallel to here. So if this is 38 degrees, remember the Z pattern from grade 9? That means this is also 38 degrees. And same on the other side. Sorry, it should be parallel. So if this is 35 degrees, then this is also 35 degrees. Good. So first thing we want to do is solve for here. So there's the diagram. B is the process, which we have solved for angle B, which we did. Two is solved for A. Oh, sorry, we did not solve for B. And 3 will be to solve for X. Okay. So process C is to solve. All right, so the first one, solve for side length B, which is right here. I'm going to split that triangle up. So I actually have a 90-degree triangle with a height of 50, an angle of 38 degrees, and I want to solve for B. Okay, again, opposite over adjacent, so we're using tan. We have tan 38 equals 50 over b. So b is 50 times tan 38, and it's 64 meters. Okay, then we want to solve for a, another 90-degree triangle, this time on the other side. So now it's facing this way. We have 50 meters tall, an angle of 35 meters, or degrees, well, and we want to solve for a. Same thing, tan 35 equals 50 over a. It's 71.4. Okay, and then there we can solve for x. And I'm actually going to do that up here where there's space. And I'm actually going to redraw the triangle, the bottom triangle there. We're looking for x. We have 110 degrees there. And we just figured out this length is 64 meters. This one is 71.4 meters. So we can do cosine law. 64 squared plus 71.4 squared minus 2 times 64 times 71.4 times the cos of 110. Okay, cos bigger than 90. It's in the second quadrant, so it will be negative. Okay, so x is the square root of 12,319.75. So x is 111 meters. Okay, so the two boats are 111 meters away from each other.